All right, so let's look at these two. So I have two Lewis dot structures, and I want to know if they're polar or non-polar. So if I just gave you the formula, if I just said ONCl or SO3 or whatever, I gave you the formula, I said, what's the polarity? You would have to draw the Lewis structures to figure out the polarity, okay? So I saved us some time by drawing the Lewis structures. So now we want to figure out, well, what is the structure? So let's look at this guy. He has 3 electron groups, 2 are bonds, and 1 lone pair. So this is a 3, 2, 1. So who's a 3, 2, 1 in my table? So a 3, 2, 1 in my table is a bent. So 3, 2, 1. 3 electron groups, bonds, lone pairs, and that was a bent structure. And we said that if it has lone pairs on the central atom, and it's not linear or square planar, then it's always going to be what? It's always going to be polar. Okay? So that easy. If we go through our chart, you just go back to your chart, use the chart to figure out the geometry, and then you can use the chart to figure out the polarity. All right, let's look at this one. So how many things? 1, 2, 3, so 3 electron groups. So the same parent group as that guy. But this case, it's 3 bonds and no lone pairs. So this guy is my 3, 3, 0 on my chart. And so that goes with trigonal planar. Trigonal planar, we said, is always going to be non-polar unless these are not the same. But they're all the same. It's all oxygens. So if they're all oxygens, it's all the same element, then we can say it's non-polar. All right? So that's the polarity. Now you might want to be wondering, you might be asking like, well, why do I care if it's polar or non-polar, the molecule itself? Like, what does that matter? It actually affects how the molecule is going to behave. Right? So let's look at this. So here I have, this is just a burette with some colored dye, with a liquid with colored dye in it so you can see it. And here, this is a charged rod. There's actually a lab experiment that we do sometimes where you take a balloon and you rub it against your head, so it's static electricity, and then you put the balloon next to the liquid and see what happens. If the liquid, so for example, this liquid is a water. So water is a polar molecule. So if the liquid is polar, that means that it has an imbalance in that pool. And so if you put a charge next to it, it's actually going to be affected by it. It will either bend to, or it actually might bend away from it, either one. Okay? So it will actually be affected, the molecule itself is affected by a charged rod. If I have something that's non-polar, for example here, hexane, it's a non-polar. If it's a non-polar and I put a charge next to it, nothing happens. So polarity actually affects the behavior of my molecules. So if I know if it's non-polar or polar, I know how it's going to behave. I know if it's going to be affected by it and bend, or if it's going to be not affected at all. Right? So this is really important to think through. Is my molecule polar, as in this case, or is my molecule non-polar, as in this case, and how is it going to affect the properties of that molecule? Okay? So that is the end of chapter 5. On the next lecture, we're going to talk about chapter 6. We're going to start talking about those orbitals again. If you remember, we talked about s, p, d, and f orbitals before, but that was for a single element. Now we're going to talk about if I make a molecule that's multiple elements together. So what happens when I do that? And that's what we'll talk about in our next lecture.